Okay, so titration is a very careful process where we want to quantify, that is, we want to know how much acid or base is present in a sample. This is used quite a lot in the real world. So for example, Chobani Yogurt hires people to titrate the yogurt to make sure there's enough acid in there for the bacteria to grow healthy. And not so much acid, though, that it would hurt you when you eat it, right? So titrations are a way to tell how concentrated an acid or a base is. As a reminder, whenever we react an acid and a base, so here's my acid, and here's my base. Every time we react, A and B are just random things. They're not actually elements. It's just generic reaction here. The H gets transferred to the base. Okay, and so the anion of the base is OH minus. So the H is going to pair up with the anion there, and so that's going to give us two H's and an O, which of course is water. And it's going to give us a salt where the anion, which is the first part of a chemical reaction, of chemical equation, the anion reacts with, the cation is the first part, the anion is the second one, and they're going to combine together, so you're going to get something like this. This is just an ionic salt. So every acid-base neutralization always produces water and a salt. Okay, so now in a titration, in order to get very careful measurements of volume, we have to use special glassware called a burette. And a burette has really precise lines on it. And they're all handmade and all very carefully calibrated. And so you always read at the bottom of the meniscus, and when you do, you always record 2 decimal places. Always. Burettes always have 2 decimal places. And so that means that for any titration we do, we get at least 3 significant figures, right? So that's how we're going to keep track of having as much precision as possible. We're going to read the burettes really carefully. And also another thing is they're upside down. So like if you look at the diagram here on the right, 3 is up at the top and 4 is down at the bottom. So we're used to reading the other direction, so it takes a little bit of practice, but each line represents 0.1. So it's going to be 3 is here, 3.1, 3.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. And of course we're going to read at the meniscus, and I think it's right aligned with that 3.9. So that means the recorded value is going to be 3.90, because I always go one more place past the marking. All right, so 2 decimal places. I would not write 3.9. That would be an inaccurate measurement, and we'll lose points on the lab for doing that. Okay. So what we're going to be doing is we're going to carefully clean the burette and fill it up with a base where we know the concentration of that base. I've made one up here. It's going to be different when you do it in lab, but it'll be, a different number, similar process. So we're going to fill it up with 1.004 molar NaOH. And then we are going to put the acid into the flask on the bottom, which is going to be very, very clean because we don't want any contamination. It doesn't have to be dry, though, because we're putting water in there anyway. So the water doesn't matter. The number of moles of acid are still the same. So we're going to put out a carefully measured amount of acid in there, and we're going to put some water in, and we're going to also add some indicator called phenolphthalein. Now you've seen this before, all right? Most of you don't, you try to avoid saying it, but I think it's fun. So phenolphthalein is clear in a low pH environment, and then it turns pink when the pH is high. So, in other words, when it's acidic, it's clear, and when it's basic, it's pink. Our task is to find the point where it just barely turns pink. That's when the titration is over. I'll show you a picture of that in just a second. Okay, so we have this data here, and so, okay, so the first thing I like to do when I have a titration problem is write the reaction. Okay, so in this case, we don't know what the acid is, but we do know that the base is sodium hydroxide. I'm going to assume that the acid has only one proton because the question doesn't tell me otherwise. And so if that's true, we would make one water and some salt. Okay, so there's the reaction. Now, the next thing I like to do is to write down what I know. I know that the concentration of NaOH is 1.004 molar, so I could write the big M, but it might be better if I write it as the fraction that it really is. And I also know that I had initially 0 milliliters of NaOH, and then when I was finished, it had 32.10. Now, when we do our titrations, it might not start off at 0. It won't start off at 0 every time. So we can figure out the volume of base by subtracting final minus initial. So in this case, it would be 32.10 minus 0. So of course it's 32.10 milliliters. Okay. Now most of the time when we're doing titrations, because we have moles per liter, we're probably going to use that in liters. So I'm going to go ahead and convert that right away. Okay, so there's 1,000 milliliters in a liter. I'm not gonna forget my significant figures. All 4 of those numbers are significant, so I keep writing them. And so now I know the concentration of NaOH, and I know the volume of NaOH. So if I take these two things together, what I can do is cancel liters to find out how many moles of NaOH were there. So liters cancels. And so this is going to equal the number of moles, which is of NaOH, which is 0.032228 moles. Now I need to check my significant figures. I have 4 here, and I have 1, 2, 3, 4 from the concentration, so I want to keep at least 4. I like to keep 1 extra until the very end of the calculation. That just helps me to keep track of everything, make sure I don't round it too soon. Okay, so now I know how many moles of NaOH was there, and I also know, I'm just going to erase the middle here, I also know that the reaction says I have 1 NaOH for every one of the acids, so I can use that molar ratio concept here. So if we have this many moles of NaOH, I'm going to react it so that I've got, for every 1 mole of NaOH, I would have 1 mole of acid. And that comes from the balanced reaction. Sometimes it might be different. Sometimes it might be 1 and 2 or 2 and 1 or something crazy like that. But I want to show this step, because if I don't, then I'm not explaining my work. And I dropped a 2 off here. So now I know how many moles of acid I have. All right. The final step to get to concentration is to take the moles of acid and divide by the volume in liters. So I think this is step 5, if I remember correctly. So we're going to take the moles and divide it by liters. They don't give us liters, but they do tell us that there's 10 milliliters. So I can convert that. You can do this as a separate step if you prefer. But that would get me liters on the bottom. So moles per liter is the goal, so that's perfect. And so when I put that in the calculator, I get 3.2228 molar. I can only keep 4 significant figures, so my final answer is actually going to be 3.223. Significant figures matter a lot in titrations. That's why you measure so carefully. So keep track of them. Okay, so this is the summary. I want to add here to write the reaction, because when you do this in the lab, you're going to know what the acid is. It's not a secret. We just don't know how much of the acid is in there. Okay, so we're going to write the reaction first, and then you follow those same steps. Okay. All right, so that's it for this chapter. My picture of a titration won't work right now, but I will put it up in the lab for you so you can see what a good titration and a bad titration look like. If you want to be really prepared so that you get out of lab on time, or early even, you can also check out a video of somebody performing a titration so you have some secret tips. And so you can search for the word titration on Google, and then click on videos, and it will come up with several different options. One of them is a Khan Academy video showing you how to calculate titration stuff, kind of like what I just did, but you know, different example. And then the second hit you get is something called setting up and performing a titration. So you could watch that, and it's a very good video to help prepare you for what to expect in lab. And that, of course, means you get to leave earlier rather than later. All right, so as usual, bring these notes into me, and you'll get credit for taking notes for Chapter 19.